Welcome. And today's concept is job controller. Hash job. kubectl API resource grep job. Hi. So this is our topic today. Job. So there is no shortcut. For cron job, you can write CJ, but there is no shortcut. And API version you see it's a batch v1. So job is a controller in Kubernetes that run one-time task. It makes sure that your pod, a single pod or a multiple pod, finish successfully. It's not for long-running services like deployment web servers. It's a short batch task like database backup, file processing, data migration, ML jobs, like things. So, how does a job work? When you create a job, it automatically creates one or more pods. Each pod runs that command or a container image you give. Once all pod finishes successfully, the job marked is completed. If we have seen a pod lifecycle, and we have every state of pod, so it's a completed. If pod fails, the job retires them until it hits the retire limits. Means if a job fails, then there is two policies, that is a restart policies. So actually there are three policies, but this job doesn't support always policy. So there are three policies: on failure, never, and always. But job doesn't support always policies because it is for a single task, and it does not mean to be all when fail. It does not means we don't want to create container or create pod. So pod lifecycle under a job: each job create a pod and watches them carefully. If the pod fails with exit code non-zero, it is considered as a fail. So when you describe anything, so there is an exit code. If it is successful completed, that the exit code is 0. If it is not, then the exit code is greater than 1, whatever it may be. Okay, then Kubernetes then decide whether to restart the container or create a new pod. It depends on the restart policies. Okay, so what is the restart policy? There are two restart policies. So here there are two restart policies, never, and there are two restart policy, never and on failure. So never means multiple pod get created. Suppose if the pod fails, so multiple pod created, and that pod is depend on the backup limit. Suppose this backup limit is 4, so a 5 pod will be created, and it is in the never policy. But when the policy is on failure, then only 4 pod will be created. He never tries the 5th one. Okay, and if the policy is never, then 5 pod will be created, means 5 times pod will be created. Okay, so we'll see this in demo in details. So backup limit is the try limit, means retry limit. This time that pod retries. Okay, and if job won't get successful, then backup limit exit error message you will get in event page. So there are two things also: completions and parallelisms. We'll see those thing in detail. So this parallel executions for job, non-parallel job, parallel job with a fixed completion count, and parallel job with a work queue. Will this thing in detail with the demo. Okay, and I am only telling you what we will cover in our job demo. So work queue job, dynamic parallel job, will cover this. Okay, I'll just give you the brief. Sometime you don't know how many tasks are there. In that case, all pod can task from a shared queue like Redis or RabbitMQ. This is called work queue job. For example, job start 3 pod. Each pod picks a task from a Redis queue, and when the queue become empty, the pod exists. The job complete automatically. It's a dynamic and no need to set completions. We can use it in data pipelines, ML job, and log processing. So these jobs are when we create a jobs, the task is completed, then also it will not delete it automatically. It stays forever. But when we don't want, why it stayed forever? Because we something whatever the job runs, so we want to cross check whether the job is this correct or whatever the things happen. So that's why. But there is a property also that the TTL after finished, TTL second after finished, if you set this second, because it is stable from the version to v23. So if you set that second, suppose let's say you set is a 60 second, so after 60 second that job is created and the pod is deleted. So job can track its pod using labels, so you can define selectors also. If pod labels and selector do not match, the job will never delete those pod. It will hang over in a completion state. Here it is expected output is not there. We'll see all things in detail in demolitions. There are suspend things also. So whenever you create a job, just for example, I will create a job. I press Ctrl L. Oh shit. So look here, suspend is true. So I'll make it false because default property is false. So k apply -f job. Okay. So job it created, get pods. So this pod is in container creating state. So whenever means these are the two state, and this is the completed state. So whenever we are in the suspend positions, means we'll discuss once again in that demonstration. But when this suspend is false, means when we suspend the job, then this container and this will delete it. This will be not affected. Okay, so this is not deleted because it is already completed that task. So we can suspend and we can resume this process. So this is for the suspend properties, and you can always delete that pod by yourself, means in the cleaning process, if TTL is not defined and you don't trust on TTL. So we'll discuss job state also. There are 5 stages: active, succeeded, failed, suspended, and completed. Okay, and the common commands we'll discuss, and we'll discuss real world example and common mistakes. And now means what is the flow of this job is that create a job controller start creates a job, pod runs and finish. Job pod run and finish is depend on that suspend process, but that is always false. If failed, then retire until the backoff limit trip. If succeeded, mark completed, and if suspended, wait until resume. After the TTL, job auto deletes. So a job in a Kubernetes is like a task manager. It keeps trying until your work is done. Clean up when it is finished, and listen when you say pause or resume. So we'll discuss all these things in detail in demo. So what we'll see in detail, that is the job basic, pod lifecycle. So what we'll see in job basic, then pod life cycle under job, restart policy, backoff limit, completions and parallelisms, work queue model, TTL second after finished, job selector, suspend and resume, and states. So these all things will cover in the demo, and demo will be a little long because we'll take at least one example of it. So stay tuned for next lecture. Till time, thank you so much for your love and support. We do have another channel which is Neokloud Hindi. Here whatever I create in Hindi, this will I upload here. So you can, if you understand Hindi, then you can have a little more content. So thank you so much for love once again.